Hi everyone, am I audible? Please confirm the chat. Okay, let me enable your mic. Give me a minute. Okay, I have enabled your mic. If any queries you can raise. Thanks for the confirmation, Sir Roy and Santosh. I associated with security. Sure, I'm going. Share my screen. Start with call. structure based in curriculum. Section 1 towards wheels services for the various both the virtualization part. If you take the virtualization, etc. And you also have a section semester year 2020 where we had section 2 and contact session 3 is section towards virtualization. Contact session so virtualization comes in and so about the and these resources are the models the infrastructure as a session 5 we specifically
Hello, sir.
yes.
Hello. Sir, you're not audible.
How about others?
Hello.
Yes, sir, you're not audible. Your voice is too low.
Please, did you ping on the chat? Sorry. How about now? Is it okay
It,
now?
yeah, it is good
It's
now.
fine.
Okay. My mic, it is. Hope it is clear now, right? Okay. Thanks for the confirmation. So, here in contact session 4, we will look in detail about the hardware virtualization of how the physical infrastructure is being virtualized and how it is shared with the virtual machines or the Dockers, etc. So here we will also see how resources are managed with respect to various services. Let's say yes, who is managing yes, who can manage pass, and the pass and SaaS are totally managed by the vendor rather than the yes is also managed by vendor, but the operating system level control will be given to us. And next is contact session 5 is infrastructure as a service, where we will concentrate on the years example. Let's say we will take AWS as an example. Okay. And I'll showcase you what are the services it has and how you can deploy services on AWS and how you can launch a website, how you can host a website on S3 bucket. So basic things I'll teach you and you can explore a lot. And contact session 6, we will look into the infrastructure managers. Okay, the virtual machine. So here you see in contact session 6, we will look into Amazon's compute, database and storage. I will also show it. I can show you a complete demo on how the compute resources can be installed with the database as well as how using the databases you can manage the storage, etc. On in the same session, we will see about the region and the availability zones. Okay. So how data center of AWS is being managed. So if it is a location wise, those are called as zones. Okay. Sorry, those are called as regions, and in every region you'll have 2 to 3 availability zone. Let's say AP South 1, like that. So like South 1, South 2, South 3, like that. So if how for data redundancy or for disaster recovery kind of a thing, they'll store the data in multiple hosts. Let's say to at least more than one host. So if you take regions, you have Mumbai, Hyderabad, okay, and so in those regions, in those data centers, you'll have multiple availability zones like ABC, etc. So if your machine is hosted in the availability zone A, you can the second for backup or the disaster recovery kind of a thing, those machines will be stored in another availability zone. So those differences we will see. And we will also see about the case study on OpenStack. So you post looking at the case study, you have to try installing OpenNebula, which is an open source cloud platform, similar to how your what is that your Azure or your Google Cloud or AWS. You can also launch what is that uh, a cloud platform itself. Next is contact session 7. We will see about virtual resources management and cloud provisioning. Okay. Here we will see how to provision a VM and how to manage it. Okay. How VMs are provisioned, how in what way, and how migration services are working. So virtual machine migration services. Let's say you can lift and shift the VMs from any platform. Let's say you want to uh, bring a VM from an on-premise data center, okay, to AWS. Okay, for that also we have tool, and then what are the migration techniques we have? So even subscription or resource group to resource group, you can migrate internally, or you want to move your virtual machine from one subscription to another subscription, and on-premise to a cloud. So various options are there. In Azure, if you see, uh, all the subscriptions will be pay as you go more. They'll be moving to another partner they call CSP, CSP to CSP migration, to Azure migration. These things will have, they will do solution assessment, which parts can be shifted, which cannot be shifted. All these things will be assessed and then technique. So contact session 8, we will review and recap the previous session so that you can get into this thing. So coming to contact session 9 is the containers. So here you will see Linux containers. Okay, like soft virtualization. So sorry. So previously we will see two kinds of virtualization. One is hardware virtualization and software virtualization. Hardware virtualization means you can buy a bare metal server and you can, on top of that, you can install the Docker or the virtualized infrastructure, let's say VMware or Citrix, okay, Citrix Zen or an Hyper-V. So any of these three, Hyper-V from Microsoft, Citrix from Citrix infrastructure, and VMware. These are virtualization environments, okay, which can convert your bare metal hardware into virtualized infrastructure, so that you can use the underutilized CPU, memory, and RAM. Okay, 1 second. So how consolidation happens? Let's say, so you consider this as a server, okay, one blade server. So hope you have seen it. Two kinds of servers are, one are tower server, which will look like desktop, okay, and one will be a blade server. So blade server has a capability of having more cores, more random access memory, and more storage, okay, and it can process as it has two processes, let's say two processes. So two processors and 256 GB of RAM and 2 TB of storage. Or let's have like that 600 GB of storage minimal. I'm telling here, just an example. Balance 1.6 TB of additional storage. Okay. So two processor, if you see so 3 GHz, okay, into two procs. Okay. So if you see, uh, let me buy this server or else this also you can have a simple configuration, one proc. Okay. One single processor, some 32 GB of RAM and 1 TB hard drive SSD. Okay. So let's say, so how I want to install a web application. Okay, I want to host a web application. So what is the size of the web application? So hosting a DB or a web, okay, a web with DB. So for web, it is if it is Windows, you use IS and you use MS SQL Server as your DB. Okay. So how you or else you want to have IA separately or MS SQL Server separately, you need two DBs, two machines. Okay. This is separate and DB is separate. Okay. With this condition, you see you have a high-end server, you have a high-end memory and storage, but your application is very less. If you say this is some 10 GB. 1 second. Let me reshare my screen. Okay. Now you can, I think you can see now. So you have a blade server like this, okay, with high configuration, and you have a tower server. Okay, this is blade server has a capability of storing two number of processors, 256 GB of RAM, and more storage, because now we are into SSD era. Okay, so simple concept you can see. So you have 2 GHz into two processor and 256 GB of RAM and some 10 TB of, let's keep it simple, TB of storage. Okay. And now if you see, You're going to host a website on IIS, okay, and which the size is very less. Okay, let's take 1 GB of website. It is going to run on this mission, and it will utilize some 10 GB of RAM, and storage is 1 GB, and the processing is very less. Okay, but if you see, this application alone will occupy the whole server. Okay, giving you an underutilized what is that server capability. Server is capable of running a huge number of applications on that, but how you will split or share those space according to the other resources, that is what the question is. That is where we are bringing in virtualization, and there we bring in hardware virtualization and software virtualization. So this containers are nothing but software virtualization. Okay, so containers are software virtualization. In that we have Linux containers. Okay, and there we will look into Dockers. Docker is one of the container framework. Okay, on top of Dockers, you can have multiple containers can be hosted using images. And then we will also study about container orchestration. That is none other than the Kubernetes service, or how to manage multiple containers together. Okay, like a cluster. So I'll try to showcase you the cluster, how a cluster is created in Azure. Okay, and then how the application is hosted on that. So as an infrastructure guy, we need to know how we can use clusters both in AWS and Azure. So I will try to give you any one of the examples, okay, on a live demo. Okay. Next is platform as a service. So in the platform as a service, we will see Windows, Azure. That is what they have mentioned. Even we can uh, see some examples in AWS also, where we can I can showcase you the platform as a service example. So platform as a service, in the sense you can directly buy a database instance. Okay, with it means the instance will be ready with the configuration, and once you give the recommended parameters, it will run for you. Okay, so it is not like you have to install a MySQL DB on a virtual machine. Okay, so that you need to buy a virtual machine and you need to configure it. After that, on top of that, you need to install the DB application into the what is that, into the virtual machine, and then you need to do all of the configurations on both the DB as well as on the infra level. Okay, whereas in PaaS services, the licenses, so still licenses I left. Okay, you want to manage the OS license for the operating system, that is managed by Microsoft. And second, for you to have a database installed, okay, what you should do is you need to install a database. You need to buy a license for that. Okay, a cloud license or an on-premise license. After that, uh, in a PaaS service, what happens is those two things are bundled together. That is the operating system and the product you want. Let's say you want any kind of a database flavor, you need to you can use it across. So those the database application control loan will be given to you, whereas the backend OS, or on which operating system it is running, everything will be taken care by the cloud infrastructure team. That is, it could be Azure, or it could be Windows, or it could be GCP. Okay, and this is what we will see in the contact session 10, and I will also try to host a web application for you on the Azure, okay, PaaS service. Next is software as a service. In software as a service, what are the various software as a service available in the market? Let's say Google has provided the development environment, which is the software development kit. okay, which is an online application available for you to develop your own application on the website using their tool. Sorry. Okay, where we will see uh, what is that? Yes. So what are the pros and cons? So as I said in your past service, okay, if you take years plus your operating system platform is managed by past service, whereas here all the three layers are managed by the vendor, that is your um, the cloud vendor. So coming to contact session 10, we deep dive little more into the cloud computing architecture, okay, wherein we see how capacity is managed. We were talking about the server, right? A blade server. We took it as an example, and where the resources are consolidated, okay, together. So that is called a server consolidation. So once the server consolidation is done, okay, what we will do is uh, we will attach, or we will get a consolidated output of CPU. Okay, if you have two CPUs, it will be grouped together, and the storage will be grouped, and it will be shared by multiple tenants. Okay, it means multiple users. So how a cloud is managing those capacity? Okay, that is what we will see here. So if you see capacity management and scheduling and distributed management of virtual machines, how VMs are moved here and there across the infrastructure. And in context session 3, we'll look after the service level agreements provided by various vendors, how they calculate the downtime. Okay, they say 99.999 percentage of uptime means that how many minutes their infra will be down on the period of a year or so. Okay, so that how resilient it is. So here you can see provisioning to meet SLAs. So if they provide SLA as a cloud provider, if you are a cloud provider, how you will meet the SLAs which is committed to the customer. Okay, that is a major point. Even some of you would have been in L1, L2 support right now, so you know pretty well about SLA, how you manage SLA for incidents based on ITL process. Similarly, for infrastructure availability, the SLAs are really important. So before that, we will see reservation-based provisioning of virtualized resource. Let's say you have a region called, if you take Azure, you have Central India and South India, okay, where you have VMs to be hosted. If even you have regions across the globe and certain take Newton, followed by cloud security, capturing all those details. So we also see multi-tenant models. Like for example, every time you will not be using your system, right? Even if you are working in front of your laptop, you will not always type something and try to execute something on on your laptop. A similar thing happens on any application. The application will not be fetched always. Okay, if it is fetched also, only certain hardware resources will be utilized for that. Okay, rest all can be rested. So that is what is shared model. So if today I'm using in this time, my same resources will be another user in the evening time. Okay, this approach is called as shared model. Okay, and the various cloud securities and the security issues we will see in detail. 14 is M14 module 14 is threat model. So what are the top 5 cloud security threats and who will be managing those security? So SLS with respect to life cycle and management. We will see traditional service level uh, agreements and operational level agreements as well. And what are the automated policy based management with respect to any of the cloud? It could be AWS, etc. So here we will see distributed file system and Hadoop. Oh, introduction to DFS, so distributed file system, and then we will also see a case study. So next is your Amazon Elastic MapReduce. Using that, uh, you can create what is that? The map reducing components with respect to Hadoop. Okay. So we will see a little about the MapReduce algorithm and how the word count Java program helps us to reduce from different service models to the MapReduce algorithm. Next is the final session will be review and recap of the whole the from contact session 9 to contact session 15. So I stop here for a short break. I am back. Let me take you to the presentation. Give me a minute. I'm sharing my screen. So for today's session, for contact session 1, the introduction to cloud and the various the role of cloud computing, which has 3 to 4 is to 5. Let's directly get into two starting sessions. You'll have theoretical topics which you need to definitely go through. So coming to the motivation. So there are web scaling problems and social networking. So information growth is huge. Okay, and mobile web applications were also huge. So this I will share you the presentation post this session so that you can read the general things. So technology advances. Okay, if you see, there are a lot of cross-platform uh, dependent and service-oriented architecture were in place where you have applications built on any platform, let's say .NET or Java, okay, or Python. You can integrate that with web services. Okay, that is what is WS standards. Okay, web services and service-oriented architecture integration with the front end or any application can integrate. Even you can integrate Google Maps into your application, right, into your website. Okay, how you are integrating it? It is a real-time data which is running hosted by Google, and you are running it on your thing, okay, on your device or application wherever you want it. So here you can see you have a bare metal virtualization, okay, and hypervisors on a multi-core architecture. So drivers for the new platform, if you see technology, economic and business. Okay, so yeah, earlier it was centralized. You have to see the shift from top to bottom. Okay, at that time centralized compute, storage, and they were using thin clients. Thin clients are nothing but you will have only a CPU and an input device can be connected to a small portable device, and which intent it connects to the server to get or process data on top of it. Okay, it's like a simple desktop without any input device or output device. So you can buy it and you can just use it across. So we used to call it as thin clients. It will not have any storage, okay, processing unit, etc. It will use the data center storage and processing capability. Coming to economic, so in those days it is very optimized and uh, it is. Someone has unmuted. Please mute. Deepak Kumar. Okay, if you see optimized for efficiency due to high cost. Okay, if you take the cost front. And coming to business, you need to pay a lot of amount for hardware and software. You need to buy data center space, you need to buy internet, you need to buy electricity for that. you need to buy a lot of hardware resources for you to farm, and also software applications. If you buy a data center license, you need to buy for the process operating system. And coming to technology, technological growth, if you could see PCs and servers for distributed computers and storage. Here you have optimization done on agility due to low cost. Okay, and you have perpetual licenses for OS and application software. The last one is your cloud. So cloud is you have a large data center and commodity hardware. You can scale out devices. Okay, it is not like you'll get exhausted. So even though you can scale to any extent, because it is they have combined or they have consolidated the hardware resources together. And coming to business, okay, if you take economic, you have better efficiency and agility. And coming to business part, you can get pay as you go model. Okay, whatever you use for that much hours, you can bill, and which will not have any license cost. It will be lesser than compared to buying a license for these many years, and maintenance cost is also not there. So just you can see how what is cloud summary. So a shared pool of configurable computing resources. Okay, you have on-demand network access, high speed. Okay, and then it is provisioned by your service provider. Cloud summary services are the data, they are hosted on a remote infrastructure. You know where the center is. So it could be in some other state. Also, it is located in. So this results in terms of it is remotely hosted, and you can access those services from anywhere. Okay, you can go to an on-site. You can sit in US and you can access the data which is in India. Yeah, or else you can host your data in US data center and you can work from UK and some other resources. And commodity. So what this model will give you, like how you take gas, electricity, right? You pay for whatever you want. So this is the definition. You can just take a look. Okay. So it provides five essential characteristics. It provides three service models and four deployment models. So if you see it is you have an on-demand network access to share the uh, pool of configurable computing resources, and that can be rapidly provisioned and released. In 2 minutes to 5 minutes, you can provision the resources and get your machines online. So we were talking about this three cloud service models, four deployment models, and five characteristics. Okay. So five characteristics you can see. One is on-demand self-service, ubiquitous network access, location transparent resource pooling, rapid elasticity, and measured service with pay per use. So various cloud definitions, you can see this a little later. So if you see cloud diagram, cloud computing is a paradigm of computing, new way of thinking how industry uh, can utilize with respect to any specific technology. Okay, as I said, utility computing, it has service oriented architecture and SLA defined. So properties are scalability, availability, and scalability, high scalability and elasticity, high availability and reliability, high manageability and interoperability, high accessibility and portability, and high performance and optimization. So how you enable all these things is using hardware virtualization, parallel and distributed computing, and web service. So now you can see the properties and characteristics. So if you see first scalability and elasticity, you can do dynamic provisioning of resources on a multi-tenancy design model. And availability and reliability means fault tolerant. How quickly you can, if your host is down, okay, how resilient your, how quick you can recover from the issue. Let's say your host is failing and you have 10 VMs running on it. Okay, you can just move those 10 VMs into another host, okay, without switching it off, and you can uh, troubleshoot the hardware issues. Okay, so fault tolerant is how quick you resume the resources which is having some issues. And then performance and optimization as you do parallel processing, load balancing, and job scheduling. Okay, so parallel processing, how parallelly two resources can concurrently work, okay, on a workload. So for that, load balancing will be there. For example, two resources are running on a bare metal server, how the memories will be shared across. You cannot say that one behind the other concurrent only it will work. Okay, it will not work on parallelly. It means not 100% parallelism will be achieved, so that your workloads gets equal amount of resources they want to perform. Okay, accessibility and portability, you have uniform access, and using thin client also you can access your cloud resources. Next is through virtualization infrastructure. So last one is manageability and interoperability. So you have control automation. Okay. So for example, you own a data center and you're going to attach a web service to it, and you're going to monitor the complete resources. Okay. And you provide billing system for your users. If you say a private cloud, they use your machine for 730 hours or so whatsoever. Okay. So central ideas, if you see from a user perspective, so user does not care about. One second. We plug the charger. So they don't care about how the backend works. Okay, what work they do at the backend. They only concern about what they get from the respective cloud, and they do not care about what the provider actually did. Okay, they want only quality of service. Okay, and they do not want to own the physical infrastructure. Okay, they want just they will pay and they will use it whenever they want to use it across. So what really the user care is, they care only the service. So still we will see some examples with respect to scalability. So if you see a desired property of system or a network or a process, so they have to handle more amount of work. Okay, they have to be readily enlarged. Let's say like you have to grow across. You have a VM and it has some limited capacity. Okay, you need to increase that capacity on the fly. Let's say 2 cores to be increased to 16 core. You need to do that. Next is elasticity. So ability to apply a quantifiable methodology that allows for basis of adaptive introspection. So actually you should also manage the space, okay? So that on a real-time infrastructure you can expand yourself. So how to achieve these properties is you can go with dynamic provisioning and multi-tenant design. So what is dynamic provisioning? Okay. So if you see you have a complex network server computing infrastructure and where all your servers are provisioned or deployed, okay, and you have an administrative console to manage all those servers, okay. So if you see server, you need to have a server administration or a network administrator. All these things, okay, should be readily available. And coming to multi-tenant design, so multi-tenant design is so you have multiple servers which can be shared as a single instance. Okay, for you to run a dedicated software, or you want to have multiple people to multiple applications or tenants. Tenants in the sense like you split those resources into multiple tenants. Even if you see a server, you can split a server into 4 boxes. Okay, so it is a single server, but you virtually you what you do is you are going to split that into 4 parts, and you're going to give it to each customer so that they will install their application, they will execute it. This kind of a model is called as multi-tenant design. So client-oriented requirements, client want customization. Okay, they want higher degree of customization to support the target of organization needs. Okay, everybody has their own business model, right? Every client or any customer has their own business model. So next is quality of service. Okay, if you take multi-tenant applications, they are if you use such thing, you need security and robustness in place, right? So next is availability and reliability. Okay, so now data never loss, machine never fails, kind of a thing. Okay, your data should be available 24 cross 7, 365 days, like that. And your machine will not go down at all until unless you switch it off or you shut down. So what is availability? Okay. So if you see a cloud usually provides this high availability for you. Okay, so 5 nines, so 99.999 availability, percentage availability. So it is like you should the machine should not or any of the parts it should not go down at all. Okay, it should be available. So even a required downtime will also be very minimal. Next is reliability. So reliability in the sense how frequently your system is failing. Okay, the specified period of time. That is what is called as reliability. So they will test it multiple times. The spare parts which is given by the vendor. Okay, if you see, uh, we will use RAID configuration for storage. Okay, so that if a hardware component fails, also the hard drive fails, automatically it will switch over based on the RAID technology. That is what is reliability. So how you achieve all these properties is you have a fault tolerant system. You require system resilience and you require system security as well. So all these things should be reliable. So if you see fault tolerant, so even if you have enabled this property so that if something fails, okay, some component fails, okay, then also your system will not come down. If a small, it is like if it is a small failure and it should not be a total breakdown. So that's why you have fault tolerant in place. Okay, so if you see basic characteristics of fault tolerant, which is the single point of failure, there is no single point of failure. So means you take cloud itself, you see multiple internet providers will be there. If one internet has gone down, okay, for a data center you have only one internet. Then how everybody will reach the respective data center? Okay, on internet. So for that, multiple internet providers will be there, dual lines will be there, dual redundancy will be there, like that. So that is applicable for all components in your server. You have a server, you have a network device. So for every location, there will be two network devices on the rack. If one fails, the second will take over. So fault detection and isolation to failing components. Okay, if you see, I can give you a better example. In the Blade server, you have multiple hard drives. So if there is a problem, it will show you in an amber light. Okay, so immediately you need to take action. This will be monitored, as I say, like fault detection. Hardware fault detection is there, software sensors will be there. So fault containment. Okay, so if there is a fault, it should not propagate to failure. You need to prevent that. And availability of reversion modes. So single point of failure. So if you see a part of the system, if it fails, still the entire system will work and it will not stop. So if you see potentially a single location of failures and critical components of complex system. Okay. How you can prevent a single point of failure? So if you see if a system experience a failure, it must continue to operate without interruption. Okay, during the repair process. So during repair, as I told you, right, you can just plug out the server, the hard drive, and you can plug in. Okay, so these are some of the example. And if the host is also having a problem, in the virtualization environment, you can move your workloads from one host to another host. Even this feature is provided by any of the vendors. Like your VM is not performing properly on a particular host in the sense server. You can shift the host from this server to another server. So that facility is also given by cloud infrastructures like your AWS and Azure. And isolate the failing component. So when a failure occurs, the system must be able to isolate the failure, okay, to the offending component. Fault containment. Okay, so as I told you, you should contain the fault. Okay, it should not propagate that failure to rest of the system. Okay, so you could see mechanisms like a ROG transmitter or a failing component to protect the system. Okay, and available of reversion mode. So the system should be able to maintain some checkpoints. Okay, so that if you are failing at this state, okay, you can bring your backup and you can check what fault you can. So all those things should be recorded. Next is resilience. Resilience is how the fault, which level your fault will be resilient. Okay, it will sustain. So the resilience is nothing but the ability to provide and maintain an acceptable level of service whenever you face some faults. Okay, so if you see resilience pertains to the system's ability to return its original state. Okay, there is some issue. Okay, your system has gone offline, and how quick you bring that back. How quick you resume your services. That is the major one. So if you see some risk events, if a power is lost at the plant for 2 days, you will not be able to run your data center at all. So in such cases, okay, you should have a redundant data center with redundant generators. In the sense, two or more generators which can take over or switch. So if you see if a key service is lost because of database corruption, okay, how you can run those business? Next is disaster recovery. Okay, so disaster recovery is it is a process, policies and procedures. Okay, which will help us to recover if there is such issues like you say, right? You have a man-made or incident or natural calamities. Okay, from that, how you can bring your VMs back. Sorry. So some common strategies you'll have point in time backup. Okay. So you can take backups in regular intervals and you can replicate data to an offline offsite location like you have from Chennai, or you can have an offsite location in Bangalore. You can replicate the whole system itself, whole image itself, you can take a backup. And preparing local mirrors and search protectors, you can have UPS in place. So security issues. So if you see, security is one of the major concerns. So it is evolving one of the subdomain of computer security, network security, or broadly whatever it is. Okay, you even set certain policies, technologies, and controls to protect the data because your data is stored in cloud. Okay, so if you see uh, in that concerns, like you have security and privacy issues, you need to concentrate on data protection. Okay, so because one customer data should not be segregated, or it should be segregated properly, and it should not be mixed with other data. Okay, because all your VMs is running for in that way only. Next is identity management. So every enterprise will have their own identity management system to control the information as well as access to the computing resources. Next is application security. So you need to keep those applications hosted on the cloud to be secure, and it should be available as a service. Next is privacy. So privacy ensures that all critical data are masked and only authorized users have access to their data. Next is manageability and interoperability. So manageability means the enterprise-wide administration of cloud computing systems. Okay, so they are hardly influenced by the network management initiatives in telecommunications. Okay, interoperability means the interfaces between the work and other products. Okay, how the access is restriction, how it is implemented, a lot of things will be there. Okay, so how we achieve these properties? We can have a control automation, systems control automation, and you need to have the monitoring. So control in the sense you need to have autonomic computing. So you need to develop a system which is capable of managing itself, like self-management. So you need to provide every time we cannot have what is that? Mm, what you have to give resources to the customer so that they will manage themselves on their own. Okay, so that's what is called as autonomy components. So which will interact with each other. So you'll have a local and global with sensors, with self monitors. Okay. So how to do planning and adapting. Okay. How to set policies for those environment. So four functional areas we have under that. One is your self configuration, self healing. Okay. Self optimization and self protection. So automatic monitoring and control of resources will be there, and it will auto discover and correction of faults. So everything will be automatic. Okay, wherever human intervention is required, there only it will intimate. And self protection is it protections around see arbitrary attacks. So all these things will be taken care. And system monitoring. So monitoring is one of the major part where uh, on a distributed infrastructure it will collect and store the data. Okay, what should be monitored? You should monitor physical and virtual hardware state, resource performance metrics, various things you should monitor. So anything more, if you see billing also is you need to monitor. Based on monitoring only, you'll be able to provide the billing part. So a billing system, how it works in cloud. So user will pay uh, how much ever he needs. Okay. So cloud provider must first determine the list of service usage price. They should fix a price and they should provide that list. Okay, so later on, cloud provider will record the resource or service usage of each user. So let's say I'm running the VM for some 2 hours per day. Okay, so 2 into 30, 60 hours per month. So, okay. So based on that, those records I should maintain and I need to charge it accordingly. So you all know you'll be seeing a pricing calculator provided by all cloud providers, let's say Azure, AWS, and Google. So there you can see for how many hours, what will be the amount will be billed to the customer. So next is performance and optimization. So high performance improvement. Okay, so how you provide performance in a guaranteed way. So it's a great computing power in cloud, right? You consolidate a lot of servers together and uh, a huge amount of what is that memory, storage, and computing capacity. You can give up to 32 core, 32 uh, what is that core also you can provide. So you can how this can be achieved is you can achieve it via parallel computing, load balancing, and job scheduling. So you have good job scheduling algorithms. They can switch the jobs whenever the CPU is idle. Okay, so that you'll have better performance. Okay, we'll have a hard stop over here and we'll continue from next session. We have some 10 slides left. Yes, I will share it right away. Okay, so that you can check in your teams. I'll share the presentation. From next session, we will be having the quiz. Okay. So you can leave. Any questions?